been a little while since I was in the city, and it's really nice to have a chance to be at this workshop. So, you maybe haven't seen me before. I'm Jonathan. I work on some Perl 6 things, and today I want to share some of that stuff with you and talk a bit about some ways of applying some of the areas that I have been working in. Now, you may be wondering, what is reactive programming? Has anyone heard of reactive programming? Yeah, okay, a few, okay. So that's great. If you haven't, then don't worry about it. We're gonna learn about what this is. So what's it really about? Well, it's really about asynchronous data. Okay, information that arrives basically whenever it pleases. It's all around us. If you're building any kind of user interface-based application, you have data, events, the user did this, the user did that, arriving asynchronously. It just happens. You don't get to choose when, okay, it just happens. When you get web requests, if you're a web server, the client sends you requests, whenever they please, they just arrive, and you have to do something with them. If you make a web request and you get a response, it just comes back when it likes. If you have files being changed on disk, and you get your operating system to tell you this file just changed, okay, those notifications just come as they want. If you have timer-based things, then each time the timer ticks, okay, every second, it's just data arriving as it pleases. Of course, Unix signals arrive this way as well. So there's lots and lots and lots of examples of this kind of asynchronous data that can just show up in our programs in all kinds of different domains, whether we're building web stuff or GUI stuff or anything maybe sort of back-endy that needs to do with time or time-based processes. Now, as soon as you start dealing with asynchronous data, things start to get really, really, really interesting. Where interesting means arg, okay? So, just consider, for example, the supposedly simple problem of building an autocomplete. And here's one from Google. Now, the thing about this is that here we are typing something in our text box, okay? It's maybe a vague relief for humanity that more people want to dine and download WhatsApp. But I guess it's popularity sort of, right? But anyway, when you send that request all over the web, then what happens is, it's going to a server, and something is hopefully going to respond. But suppose the user types something else into the text box. Then we send another request off to the web server, okay? Because we know we need an updated set of things to show them. And it turns out that second server we hit responds very quickly. We show the data, and then the first one comes back with its response. And of course, if we've just written some callback so that when it comes back, we update the box, we're going to screw up. We're going to show the old response instead of the one that corresponds to the latest data the user gave us. This is just sort of typical of the kinds of problems that asynchrony gives us. And this isn't kind of easy. Now, you might sort of say, are we talking about threads here? And the answer is, well, no. You can have all of these problems without any kind of threading. Okay, you can actually have a single-threaded application that's vulnerable to exactly that bug that I just showed you. How do you know? Well, you can create it in JavaScript, and JavaScript typically does not have threads. But sometimes we need to bring threads in. In a lot of modern ways that we build web applications, we respond to different web requests over different threads, just so we can get better efficiency. Or if we're building a user interface application, users really hate it when they're using an application and they do something and it freezes and it won't listen to them at all for a few seconds until it's gone and figures out the result, and then it behaves again. That's not a good user experience when we need to do those things. Typically, we want to take the work and shove it off onto some thread in the background, and guess what? The result arrives asynchronously whenever it pleases. It doesn't matter if we're in the middle of dealing with a different user request. Okay, we might get back this response, and somehow we need to get the user interface updated in a good way that doesn't sort of cause problems. So basically, these are hard things. Okay, these are really not nice problems to have to deal with. But well, let's put that aside for a moment. Let's do something easy. Okay, it's still morning. I'm still drinking my coffee. Let's talk about synchronous programming. This is the one piece of Perl 5 in my talk. It's here to prove I can sort of still write Perl 5. And what's it doing? It's going over checking we didn't reach the end yet, it's reading a line in, and it's skipping any lines that start with comments, and then it will do something else. This is an example of what we might call the iterator pattern. What we're doing is taking this file handle, and we're able just to pull things out of it. Okay, that's what this line here is doing. Okay, we're sort of pulling a value, pulling a line from that file handle, and it means we can just move through the data a little bit at a time. Okay, and we've actually sort of realized that's a very sort of common and important thing to want to do in Perl 6. And there's various things that you have in Perl 5 that are good at basically taking data and working through them. And grep and map and sort are a couple of simple examples. And we have a few more of these in Perl 6. Let me just give you a small example. Suppose I have a frequent flyer program. And I'm going to get the gold members, okay, the members who have gold status on my program. I want to grep out those that have more than 10,000 points, okay? And what's this star dot points thingy? Well, that's a nice way of writing a block containing $_ dot points, and it actually is sensible enough to say, oh, you probably want to drag this greater than in as well, so it does that, okay? So we get a nice little block being passed in there, which just saves us writing the curlies and the underscores and so on. So here we get all the members that have more than 10,000 points, and they are entrants to our little competition. And then we pick 10 winners, okay, that just picks 10 things at random from the list. And then we want to get the names of the winners, so we just use map, and again I use this little syntax, okay, that gets me the names of the winners. Now, how does this relate to the iterator pattern? Because of course, if you grab the map on Perl 5, you know that it takes an array with all a list of things, it goes through them, and it gives you back an array, and all the work is done. Well, let me just show you something else you can do in Perl 6 that you can't quite so easily do with, or can't really do so nicely with grep in Perl 5. Here is the Fibonacci numbers. What are the Fibonacci numbers? It's the numbers starting with 1, and then we have another 1, and then the next number is obtained by adding whatever and whatever. That is 1 and 1. Okay, that gets us 2. The next number is got by adding 1 and 2, which gets us 3. 2 and 3 is 5. 3 and 5 is 8. Okay, and you'll notice that I've decided that I'm going to have an infinitely long list here. Okay, this is we call this the sequence operator. You can kind of guess how it might be working here. But of course, the problem with this is that that list is infinitely long. And you might say, that's great, but my computer doesn't actually have infinite memory. Well, thankfully, we used a binding here, which actually just says, I want to give the name at fibs to this thingy that I've declared here, but I don't want to evaluate at all. Okay, to avoid confusing Perl 5 programmers, assignment with equals is normally ego. So, what we do here is we actually grep this infinitely long list. Okay, and of course that gives me another infinitely long list of just even Fibonacci numbers. And of course this infinity is getting a little bit much for us, so we say, you know what, just because I could have them all, I'm actually only going to take the first 10. And the thing that you might be thinking at this point is, well, that's great, Jonathan, but I don't care because I never have to use the Fibonacci numbers in my program. Has anyone ever used Fibonacci numbers in a real program? No. You have? What for? This is the first time I've given this talk and someone said yes. I'll talk to you after.
For the pooling or resourcing loop and waiting.
Oh, the Fibonacci numbers are a good Oh, that's clever. Oh, that's awesome. Thank you. Anyway, so now you can lazily generate Perl 6. Okay, you're happy. For those of you who don't immediately have such a use case for the Fibonacci numbers, what else do we want to work through that's maybe not infinite, but that we want to do a piece at a time? Well, perhaps a really big file. Now, in Perl 6, we can actually quite happily just go and do a for loop over the lines in the file. What on earth is this pointy thingy? We call that a pointy block. It's actually the way you write a lambda or a closure that takes some parameters, or a block that takes some parameters, however you like to think of it. And that actually, because that's the parameters of the block, there's no need anymore to sort of guess what is the scope of the my variable that we are taking the lines of this file and we're not grabbing them all into memory so we can do a for loop over them, we're moving through it a line at a time. And of course, because we know that grep can be used on things where we don't want to get really important ones, we just want to do it a bit at a time, we can grep the lines. So we can grep out all of the ones that don't start with hash. Okay? I just use the quotes instead of the backslash there and a little detail. So, if you think about what grep and map are doing for us, they're basically letting us take bits of flow control, okay, things like loops and if statements, drag them out of our code and make an abstraction. So when we talk about grep, okay, we know that internally it's doing some kind of looping and some kind of if and so on, but we don't have to think about that. We can work at a slightly higher level of abstraction. We can say filter out the things that match this, okay, we're done. And other ones actually do even more for us. So if I do .unique here, okay, so I've got two sets of search results from Bing and Google, okay, probably some pretty awful ones and some pretty good ones, but they may overlap occasionally, right? So what I want to do is take all these results and just get the unique ones by URL. So what I can do is unique. And if you think about what unique is doing, it's not only factoring out a loop and maybe some if statements, it's factoring out a hash. There's actually a little bit of data inside of that. So we're dragging state out of our program using these things as well. And that's really nice because that means we don't have to look at our code and sort of say, oh, it's doing some hash thing and so on. We can just look at it and say, oh, it's getting the unique ones. Okay, just raising the abstraction level in our program. So the thing about this is that we know how to do it for synchrony. But what if we could do the same thing for asynchronous data? What if it was nice and easy to grep an event stream or map an event stream? If we can do that, then we can actually perhaps take all of the things that make asynchronous programming hard and drag the hard things out of our code and make somebody else actually deal with implementing them. Somebody like, say, Liz, who's actually been implementing a lot of stuff I'm going to show you. Now, we could also, if we can nail this, be able to compose different kinds of data from different kinds of asynchronous data sources fairly easily. So we know that we can take, a list of products and a list of customers or orders or whatever and be able to match them all together using various different kinds of list operators. Well, it'd be nice if we could do that with asynchronous data as well. And what if it could be made easy to just take some work, throw it onto another thread, and get the result back and have it all not hurt? Okay, if we can figure out a nice way to do that, that would be really great as well. And if we can somehow find a way to take all of these nice things that we get in synchronous programming with lists and drag them into the world of asynchronous programming with time, with things on the network, things in the file system, things from user events, okay, maybe this would be really, really nice. Does anyone know category theory? See, yeah, that's not many. And the people who are in the room who mostly have seen this before. If you know category theory and Skyrim, this is really, really, really funny. Unless you've seen it 10 times already, in which case it's not anymore. So what on earth is category theory? Category theory is a thing that involves lots of arrows. And why is category theory interesting to us? Well, it's interesting because it actually helps us uncover relationships between different things that might not have been very clear to us. For example, if you look at iterators, okay, a thing where we can pull the value at a time. That's what we do in a for loop. We say, give me the next value, and we do something. And grep is a thingy which says, give me the next value, give me the next value. And then it passes on the ones that it thinks match, okay, to the thing that asks it for a value. So it's a big pipeline. But if you kind of look at the observer pattern, what's the observer pattern? It's the pattern where you go and say to something, I'm interested in knowing what happens, okay? And every so often, it'll tell you, oh, this thing happened, okay? So you can observe maybe a button on the user interface. And every so often, often it will say, got clicked. Okay, got clicked. You just get told. If you think about it, it sort of looks as if these two might sort of have a relation. And when they're looked at in category theory terms, they actually turn out to be something we call duals. Now, a dual basically tells us that if we can sensibly define things like map and grep, and all these other operations on one type, we can also apply it to its dual. What does that mean? Well, if you think about what the iterator pattern is, it's synchronous programming. Okay, you're waiting for the next value. If you think about what observers are, they're asynchronous programming because we're getting told the values when they're ready. So if we can really say that an iterable and an observer are dual, that means we can write all of those nice things that we write for iterables for observables. And we can factor out all of that tricky stuff, okay, into the map and the graph and the whatever implementations for these types. And if you think about it, that's really nice, because that means we potentially now have a way to not only just factor out the things like filtering and mapping of these events as they come in, but we can actually start writing things where we factor out thread safety and synchronization and getting things onto the right thread and pull them out of user code into some nice, neat methods. Okay, so let's try and do it. So in Perl 6, we call a source of asynchronous data a supply. Here's one of the simplest ways to get a supply. We say supply.interval, as in a 1, okay, and that's 1 second. And what this will do is it will give me a supply of ticks, okay, 1 every second. Actually, what it sends me is an incrementing integer, a 0, then a 1, then a 2, and so forth. Now, if I actually want to start getting the values, what do I do with the supply? Well, I tap it, okay? So I tap the supply, and I give it a block, and every second, this block is going to be run, okay? That wasn't so hard. But because this is something where we know it's an asynchronous source of data, it works like an observable, we can map it. So what I can do is every time a second comes through, okay, the number gets pushed through, I can take it and I can do modulo 2, okay, and I can decide whether to say tick or top. And then I can tap this thing, okay, as say when you put an ampersand before something in Perl 6, you're actually saying I want to talk about the function as a noun, okay, I want to call it, I want to talk about it. What it's going to do is it's going to say tick, tock, okay, like this. Now you might be wondering, where the threads come into this. The answer is that they come in when they need to. This previous example here introduces threads, okay? And it does it because we don't actually want to block our program up at the point that we tap this thing. So what will happen is that we will start getting this say run on some other thread, and we can use the main program thread to go and just get on with stuff. But supplies don't have to be used like that. In fact, you can use them as a very simple publish-subscribe mechanism. What you can do is you can make a new one, you can tap it, and then somewhere else in your program you can just throw things into the supply. You can just say more, okay, that means another value. And what it will do is it will just send that to anyone who's tapped it. Many people can tap the supply, okay, and they've all managed to get the values that we send along. Okay, so that's a little introduction, but of course, that was just toying around. So let's actually build something vaguely interesting. So, who uses Git? Okay, everyone. Git is awesome. So, I really like Git because it makes it really, really hard for me to screw up, even before I have my coffee in the morning, okay? It basically makes it so as soon as I give my stuff to Git, it knows, okay, you gave me this file, I'll take care of it. Okay, later I may change it, give it to Git again, and it says, okay, I'll take care of that as well. It's very, very, very hard to actually lose something with Git. It keeps a lot of history, and it keeps a very good can lose stuff. And that is when you're busy, editing things, and you do a whole load of stuff, and then you suddenly realize, wait a minute, I did a change, I just deleted this thing, but I hadn't actually committed it at any point yet, and oh no, I lost it. So what I just wondered about is, what if I could implement a tool that between two commits logs all the changes to the file I make, and then when I go and make a git commit, it just throws away those backups instead of giving it my files. So, how do we write it? Well, let's start out with this sort of simple thing. You know how it's easier to destroy stuff than to build it? Okay, so let's start out by destroying stuff. So, what we'll do is we want to delete all of the backup files as soon as somebody commits. Now, I'm going to keep my backups in a little .intercommit directory. Okay, so what I'll do is I'll run this in a Git repository, and I'm going to take this notification class. We actually built this in to Perl 6, and we say watch path, and we give it a path. And I've just given it the git logs head. It turns out this is a very safe thing to watch if you want to do something whenever head changes, which basically means we made a commit. There's a few other reasons as well that tends to mean that. So this is a supply of I/O notifications. Okay, a supply of the file system saying this thing changed, this thing changed. So I can tap it. Okay, and I can say, oh, a commit. Okay, whenever a commit is made, we just output that. Okay, fine. So of course that doesn't do anything too useful. So here is the more useful thing. We'll just take the list of all the files in the directory into commit. Okay. I grew up on sort of MS-DOS, and I kind of find it comfortable that the thing that lists files in the directory is called dir. It's like a flashback. And anyway, there we go. Okay. Notice that you can actually just loop over directory listings. Underneath, it's actually lazy as well. It won't pull the whole thing into memory if you have a file list of 20,000 things. It'll actually just let you pull them lazily. So we're getting lazy lists to the rescue. So now we know how to delete all of our backup files. How do we make them? Oh, that's more interesting. So it turns out that if we watch a directory, we actually get notifications about the changes in that directory. If I just watch the dot directory and I tap that supply, and I just say change happened, then what we see here is that it's just going to be giving me these objects. Okay, so it'll tell me that this changed and this changed. Now, if you've ever worked with file notifications, particularly on Windows, you might have discovered that the APIs to these things and their behavior is really, really, really horrible. And the reason it's really horrible, I make one change to a file, and in the space of like 0.01 of a second, it throws two notifications about the change I made. I'm like, really? And I was like, have I implemented this wrong? So I went off to C# and .NET, and I wrote the same program, and I got the duplicates there too. So it's like pretty Windows fault. Anyway, basically, what I wanted to do is somehow try and get rid of these duplicates. Okay, that sounds like a slightly annoying problem. Well, let's have a look at how we can do it. So what we'll do is we'll watch the path dot, and then all I'm going to do to get rid of the dedupes, is I'll use unique, and I can unique it by the path of the file. But of course, this is not quite enough, because of course, if I save the file and then like a minute later I save it again, those definitely are two separate changes. So on a bunch of the methods where we saw unique earlier on lists, okay, the as is the same, that's familiar. But on a bunch of the methods that we've implemented for reactive data, asynchronous data, we've realized that time is also a very important axis. So we've actually added extra options to some of them to deal with that time-based nature of the data. And one of them is called expires. And this one's actually quite important for memory management too, because of course an asynchronous program can just be living on and on and on. Whoa. I think it's okay. So, we'll be fine. That's only the house on. Okay, so what we'll do over here is move the glass away.
Yes, I've got the side of the table.
How's that? Yeah, whatever. Okay, so what we know is that, of course, if we just keep building up data that we've already seen, at some point we might things away. But in this case, we have a pretty short expiry time. Okay, after 1 second, we sort of say, okay, we've seen enough, and if they save it again, okay, it's not a duplicate. So that's quite a hard problem solved in a single line of code. I like this. Now, here's the bigger thing. Okay, it looks like a bit of code, but let's just take it step by step. So the first two we'll see. Okay, we watch the file, it expires after a second. Now I'm only interested in the path itself. Okay, I'm not interested in the whole change object, just the path. So what I'll do is I'll map out the path. And when I first built this, something really funny happened. Okay, what happened was I found that when I backed up, I made a change to the backup directory, and it said, "Oh, you just made a backup, and you changed the file. You better back that up." So it backed up the backup, and then of course it said, "Oh, you backed up the backup, so you better back up the backup, the backup." And yeah, it made a lot of files very, very quickly. So we'll actually filter that out with Fred. Okay. And then, what we can do is cap that supply. And here, we'll just increment this change ID, okay, so a number that we increment there. And I have a little index file that keeps track of all the backups I have. Slurp, you maybe know, Slurp reads a whole file into memory at once. We searched long and hard for a non-disgusting word for getting stuff into a file. We rejected spew, we rejected spit, and we ended up with spurt, which of course is completely innocent. So here, so what we can do with spurt is we can give it the file name and we give it the data, but we can actually also give it a named argument here. Liz showed you the colon pair syntax. What she didn't mention is that if you just say colon append, it's the same as passing append true, okay, as a pair. So that's a nice way of actually just passing true off to something. And that means we can very easily just append single lines to a file. Okay, I like that. And then we'll just copy the file that we're backing up to that number in the backup directory, and we're done. Well, we're almost done. You see, these notifications are, where are they handled? Well, they're handled by some thread. And what if 2 notifications arrive? Well, that's kind of interesting, because actually, if the thread pool is kind of busy processing one of them, it'll just find another thread to deal with the second. Okay? And it can have a whole bunch of these threads sat around waiting to work. So, when we actually start doing things like ++ change and appending to files and so on, let's just be a little bit careful, because we might actually end up in this particular bit of code on 2 threads at once. And of course, incrementing this state variable on 2 threads at once is not going to end very well. So we can actually tell it that we're doing something that has consequences outside of our program. We don't say tap, we say act. And if any of you have ever worked with actors, okay, then the actor pattern, this probably will make a lot of sense to you, because actors are all about objects where you can only be in one method at a time, and you call them asynchronously. So that's kind of the cute bit of the name, for those in the know. For those who don't know that, then you just sort of say, oh, we take some action, okay, and that works just fine as well. So this makes sure, it promises you that you will only ever, on 1 thread at a time, be running this particular block of code here, and that very nicely deals with the problem. What will actually happen though is that suppose I get 2 duplicate notifications. Okay, the first one will flow, remember the flow is this way, okay, the data is pushed through the pipeline, and it'll get pushed into here, and then we'll say, oh, it's fine, we haven't seen it in the last second. This first thread will be very busy working on this. The second thread will get into this, and actually, I mentioned we factored out synchronization. Inside of Unique, we actually do all of the necessary locking and whatever to make sure that we don't get wrong answers, okay? So inside of there, we'll actually, on the second thread, very quickly just throw away that value at this point, and then it's free to do something else. Okay, so how did I put this all together? Well, I put it in a class. I wanted a log to show what it was doing, okay? So actually, let's go and just run this thing. Oh, water everywhere, awesome. And, okay. So what I can do is I can just start up this intercommit watch thing. Okay, we can just go over here. Let's create a file. I think I've got let's echo something to this file here. Okay, and over here we should see that it made a backup of that file. And if I change that to something else, okay, and then I can just intercommit list, okay, and it will show me a list of the things that it has backed up. And oh, I actually need one earlier when I was playing with this too. And anyway, now I can intercommit show one, okay, there's the backup there, 2, okay, there's something 2, and if I git commit my awesome change now, okay, whoop, git commit, and what's the final? Okay, and if we go and look over here, you can see that it did the 2 backups, it cleared the backups, and now it intercommit list, okay, is now empty. So fine. Alrighty. So how do we put the pieces together? Well, that log is just a supply. Okay, it's a log is just a source of things that you might be interested in that get thrown at you. Great. So then I'm going to write 2 private methods. One that watches head, that's my first bit of code. One that watches the directory, that was the second bit of code that makes the backups. Okay, and then all I have is a few main methods. These are really nice. If I actually was to forget how to use my tool, I could just type intercommit, okay, and you can see down here, you've actually got a usage message telling you do watch, you do list, or you show an entry, okay. Where did that come from? Well, it turns out it's generated by the different main methods that I write. And you can see I wrote it as a multi. I said this is the candidate, the one to call when I put watch in there. So there we're just checking if the file exists, okay, and we're tapping the log. And actually our main thread doesn't need to do anything much in this program, so I've just said, oh, just leave forever, okay, and all the rest of the work actually happens asynchronously over on various threads. So it's kind of nice. The whole program is there. There's the class, okay, there's the first query, the second query down there, and here we have the various multi-candidates for name. Okay, so that's kind of nice. Okay, that's one source of asynchronous data. Let's compose 3 at once. Okay, one was far too easy, so let's do 3 at once. I can't see to the back of the room. What does that say? Someone was holding a number up. I can't see that far. That's awesome. I hope it's a 10 or something. Okay, so... Okay, so let's do 3 different sources of asynchronous data in 10 minutes in one program. Okay, how hard can it be? So, what I want to build this time is a little code golf assistance. Does anyone play code golf? Okay, the thing where you're trying to get the code as short as you can, get into the least characters. So, I actually built a little tool where you type code in here, okay, and here it automatically tells you how many characters you've got in that text box, and it changes as you type. And down here, it shows me how many seconds I've wasted so far, so this is just ticking by, on and on and on, okay? And here it shows me the results of the thing, and that one actually is going to run off on a separate thread, because I don't want my user interface to get all unresponsive. So, how do we build it? Well, first of all, we just set the window, okay? So what I'll do here is I'll just make a new app. The title is called Golf Assistant. I will here have a vertical box of controls. So we have a text view, we have a label, we have another little label, okay, that's my one for time elapse, and here I'll have a text view for the result, okay? So text view, labels, text view, okay, arranged in a little vertical box. Kind of easy. And I'm just putting them into variables because I want to talk about them later. Alright. So let's do the easy bit first. What we want to do is every time we type something into this box, we want to have that character count updating. So what this module GTK simple does in Perl 6 is it just exposes every event as a supply. So all I have to do is tap the changed events of the source text box. And as soon as I get one, all I'm going to do is just take this chars label and say the characters are the number of characters there. By the way, you can actually interpolate method calls in Perl 6 as well. Okay, it's kind of nice. Just make sure you put the friends on the end. Okay. If you don't, then we've done that so we don't screw your file extensions up. Righty. Let's do the next bit. So what I want to do is I want to every second, okay, have a tick, okay, and update that little elapsed text box on the UI. Now here we need to start being really, really careful because I told you earlier that interval, okay, is just sending these notifications off into the thread pool. Now if you've built user interface applications and done threads all at once, you might have run across the issue that you can only update the user interface from a particular thread. We call it the UI thread. And this is going to basically end up crashing our application at some point if we're not very, very, very careful. Okay, because what's going to happen is this bit of code here runs on a thread, but it tries to update the UI, and that's an illegal operation. So how do we deal with this? It turns out in Perl 6 at the sort of base of it, all concurrency is based around schedulers. A scheduler is very simple. It's a thingy where you give a piece of work to it, and it tries to make sure that it gets done. Okay? And you can tell it, normally you give it the work and say do it as soon as you can, but you can also give it work and say, well, do it in a second, or do it every second. Okay? And all the concurrency stuff we have is basically built on top of schedulers. Now, what I did is I wrote a GTK simple scheduler. GTK simple scheduler basically is something that accepts work and shoves it into GTK's event loop so it gets done on the user interface thread. How do we use it? Well, it's like this, okay? We take our ticks, so that tick arrives on a thread in the thread pool, and I just say schedule on this scheduler, okay? So what I'm doing is I'm taking this work, this asynchronous data, and I'm just tossing it over to the user interface thread. And then here, I tap it, and I know now that because I said schedule it on the GTK thread, this is going to run in the right place, okay? So we're done. So that was a hard problem solved in, one method called the schedule one. What about running the code? The bad way to do it is just to run it synchronously on the user interface thread. Okay, that would kind of suck because, of course, what will happen is that if it takes like a second to run, we're going to sort of block up the whole UI and the user won't be able to type anything or edit anything. So this is not a good way to do it, okay? Because we eval the text and we catch any exceptions and we show the message instead of the, just throwing the exception. That's okay, but the problem we have, of course, is we don't want to just be freezing the UI up. The other thing is that we don't want to do this every time the user types a character. Okay, so they're typing, they hesitate for a moment. That's when we want to automatically run the program. Okay, not every single character that they type. So let's solve the two problems. Solving the problem of needing to have a value that hasn't changed until a certain amount of time is abstracted away into the stable method. So what you do is you say I have this source of changes to the text box, and what I want to do is I want a stable value in the text box for 1 second. Okay, so you wait for a second for the value not to change. So that solves the first problem. What about the threads? Threads, they're like this, okay? Well, what we want to do is we want to kick the work off on another thread, but we know that we have that base condition. Remember autocomplete right at the start of the talk, okay? How do we solve that problem? How do we deal with the result coming back from one thread, and then the user changes the program in the meantime, and the quicker evaluation sort of wins, and then the first thing, which was taking a while, comes back with a result, and we show the user the wrong result. That's a problem. So we need to deal with that as well. So first of all, how do we run code on another thread? Well, Well, you just say .start, okay? What this does is it basically, instead of running this block here on whichever thread the event originated from, okay, this is a user interface event, so it originates from the user interface. What this does is it says, oh, whenever a value arrives, just run something off on in the threads, okay, the background thread. So it does that. And this actually, what does it give me? Okay, because it can't give me a value yet. What it actually gives me is a supply. It gives me a supply that later on in the future will have the result of this bit of code pushed into it. Now, if you think about it, that means that I now have a supply of supplies, okay? I have an asynchronously updated source of asynchronous data. Now, that sounds kind of weird, but it shows up all over the place. If you have a little application on your phone which is showing you stock prices, and you have a page for each stock, okay, and you have the stock updating with live data to the second, then what you'll have is you'll be flicking across the different things on your phone app, okay, moving between them, and that, of course, is an asynchronous event, okay, and each time you want to go and get the stock stream for that particular stock, so you can be watching that, okay, and as you move between the pages, you're switching between these different streams of stock prices. So it's quite natural to have supplies and supplies. The only question is, how do we flatten them out? And the answer is with this really, really pretty thing here called migrate. Okay? Migrate basically lets you move between sources of asynchronous data. So what happens is we start off the first bit of code the user wanted to run. And while that's running, okay, they change the value again, and it's taking a while. And the second thing they run is really fast, okay? So what will happen is that we'll actually get that new incoming answer, okay? It hasn't arrived yet. And migrate will say, well, ignore the previous thing, only pay attention to the new thing. So at this point, what it's done is it's been giving me a stream of the latest values, okay, and we've safely shoved away the old ones. What I can now do is just take all of that work, okay, and say, well, I want to update the user interface at the end. So here we went off the threads, okay. Here we dealt with the race condition that could happen. Finally, I want to update my user interface with the result. So what I'll do is I'll schedule on GTK symbol scheduler. I'll just tap that. I'll just put the code evaluation or the error message into the text box. Okay, obligatory live demo. This one's running in my VM over here. So here we go, okay, and that gets started up almost right away. So you can see, I hope you can see, the seconds are ticking by here, okay, and if I go and type 1 + 1 in there and just hesitate, okay, it says 2. If I go and start, doing something more interesting, so maybe we'll have the 10th, I don't know, we did Fibonacci earlier, right? Star plus star, you can see that it's not, I didn't type fast enough, so now it's telling me it's an error, okay? This could actually be a nice game. You know, you have to keep playing at high speed until you don't get an error. Oh, I missed out the friend. And, there we go, 89, okay. Well, I think that's the right answer. I can actually get the first 10 of them by putting my hat in. Whee! Okay, I like this. Okay, oh, I wasted 49 seconds on that demo. Awesome. So, okay, so the final thing that we do at the bottom of the program is app.run, okay, to kick all of this off. What you might have realized at this point is we didn't write very much code. Here is the complete code for my app. It's 29 lines long, okay? Well, 28 if you don't count the last empty line. And there's lots of empty lines, so it's actually less, but I like to space my code out and make it look pretty. Okay, prettiness counts as lines. So, but what you kind of realize is that we just did a UI, we did multiple threads, we dealt with race conditions, okay, we made a nice responsive experience, and we did it all in 29 lines of code. To me, that's kind of nice. So, just as a complete aside, I don't really have time time to talk about this, but you might wonder how is that module implemented? Is there loads of nasty C code behind all of this? The answer is no. Actually, it's built using Perl 6's native call module. So all of the GTK simple module is written in Perl 6. Okay, not a single line of C in any of this at all. And you might say even the event loop, even the place where you hooked into GTK's event loop didn't need any C code. No, I could do it all from Perl 6 native call. Okay, it was actually not too hard. Actually, it was sufficiently easy that they wrote it. It worked. I couldn't believe it worked, so I spent 10 minutes trying to figure out why it looked like it was working and it wasn't. And it turned out it was actually just working. Yeah. But what we actually do is we go and call GTK's signal connect thing, and here we actually produce a supply, okay, and every time we get this C callback from GTK, we just put the value into the supply, okay, and if there's any errors, well, no, we just move them, but we could do something smarter than that. Okay, so let me wrap this up a bit. So asynchronous things aren't that uncommon. I think they're getting more and more important in the world around us. Traditionally, we use mechanisms like callbacks and event loops which don't always compose very well. Here, definitely there were event loops going on, but I didn't have to think about them. And I could treat the events as first-class objects, grab them, map them, okay, do all of these various operations. Reactive programming as a paradigm basically lets us do a lot of this factoring out of things that traditionally have been quite difficult to pull out of code in asynchronous programming, and they allow sort of easy composition. So in that 29 lines, okay, I had time, I had UI events, I had threads producing results asynchronously, okay, 3 kinds of asynchronous data just composed very nicely together in a simple bit of code. Really the goal here, Perl is about making the easy things easy and the hard things possible. And here I wanted to make the easy asynchronous things easy. And of course there's stuff beneath to go and let you do the hard things as well. Okay, so I couldn't see the number on the back of the paper again, but it was waved at me. That might mean I'm out of time. Do I have time for questions? Do I have any questions, anyone? No one has a question. Okay. Then either you understood everything or nothing, which is a scary thing. Okay. Well, I hope this has been of some interest, and I'm around for the rest of the day, okay, all of tomorrow. I'll have a talk tomorrow on making some of the easy synchronous and normal things easy. We'll go and port a 12.5 module over to Perl 6 together and see some of the normal or everyday things. So that's a question.
One question? Yeah. Is it possible in Perl 6 do auto-parallelization of code?
Auto-parallelization? No, but we have various ways of making it very easy to declare that code can be parallelized. For example, if you have a list of items, okay, and you want to, this is not a very expensive operation actually, but well, we can -3 to get the absolute values, okay. You can say it's 1, 2, 3. Now, of course, abs is a relatively cheap operation, but if you imagine you had a U-choose list and you wanted to do a fairly costly operation across all of them, this thing here, the double angles, actually is not only doing it over the list for you, it's saying to Perl 6, I promise it's okay if you go and spawn multiple threads to do this over. Now, one place that we're likely to use it as well is that actually people sometimes say, this one looks silly, okay, if I want to add all the numbers together into arrays, and really do I want to spawn multiple threads off of that? The answer is no. That one, if they're 2 arrays of native integers, are what you want to use your SIMD instructions in your CPU for, okay, and get your CPU to do its vector map stuff on it. So again, we can do that on native arrays. We'll have to teach the JIT stuff some really fun tricks to do that. But yeah, for more normal operations, you have ways of just declaring this is okay to parallelize. Another one you will be able to do is, you know how you can map things? Okay. Well, you'll be able to do a bunch of like that, and the hyper in there actually is telling Perl 6 it's okay to break the list into chunks and run the map blocks on different threads. And of course, it's your responsibility not to do any side effecting things in there. But so it's not quite automatic parallelization, but it's declarative parallelization. So you just say it's okay here, and it will go and do the cost analysis and the work balancing for you. Does that help? Yes? Okay. Okay, I probably really am out of time. Let's save it around, so feel free to ask me anything you like over the coming days. Thank you very much.